Hello everyone, so today I'm going to be going over how to do the HISAT tutorial, and we're going to be doing the first part of it. Essentially what we're trying to target is getting a SAM file out of this, so that's going to be our output. I have done this, so I'm just going to glance over some of the steps. The first thing we have to do is actually get our data, and we're going to be getting that through the Johns Hopkins University website. So we're going to be doing that by using FTP. So what we will do is we will make our FTP connection. So FTP, and then we'll do ftp.ccb.hu.edu. So this is telling it to use the program FTP, and then that is our link where we're going to be getting our data from. So we'll start a connection. It tells us instructions there on how to log on, so I'll just put FTP, and then I will put no password. Now we're in. We can use ls, and this will show us where we are, so we can obviously change directories to our pub folder, and then after that we will change over to the RNA-seq _protocol directory. Sorry, I keep saying folder, but it's a directory. So now we're in there. Now we can do ls, and now we're looking at the files, or some of them, that we're going to need for this. Now we know that we have to get this chromosome X data right here, which is going to be our sample stuff that we're working with, and we are also going to be getting this annotated GTF. And you would do a simple get command, and you would put it into your specific folder that you want to go into. Now when I did this, I built a working directory, and I went over here. I just put it right on my desktop, HISAT tutorial, and this was my working directory, my HISAT. So as you can see, I do have my SAM file here. So the next thing you do is obviously you need to download HISAT. So the way we do that is we would go under the website, and we'd go to ccb.jhu.edu. HISAT2. Go here. And essentially what I did was I went ahead and downloaded Linux binary, and I mapped it into a folder over here in my home directory called bin. So here's my bin folder, and it shows our IGV and as well the HISAT2 program. Now in order for that to run, we had to set that up with a path. So we had to put that into our path, and what I did was I can actually close this connection since I already have that data, so I'll just do exit. And what I did was I used get it, and then here we go. So what I did was I went ahead and exported my path over here. So path equals path. This is where I put that bin file, and this is essentially telling it, okay, so these programs are here, you can run them from here. So we can go ahead and close that now. So once that's mapped, this closes, it starts a new line. Now we can go ahead and set up the program. I went ahead and set that up beforehand, and I actually have a file over here under my working directory. Desktops, HISAT tutorial. So this is my shell, or I apologize. That's where I put it. So here it is. I just called it chromosome X nomenclature. And essentially what you do is you call the program HISAT2. I did not put performance in, so I'm not worried about the amount of processors. And then I mapped my indexes. So where they were located was home, arrays UNR, desktop, HISAT tutorial, that's where we're at right here. And then we went to chromosome X data, and I mapped it to indexes. So here's that, and essentially what you do is you do chromosome X underscore tran without the .1.ht2. Afterwards, you need to map where your data is, your samples. So you'd go to samples, and let's say we're working with the first one. So the first one is ERR 188044, and we have two files. We have one and a two. So what we will do is we go over here, and we have that mapped out. And the first one was number 1. Here's the location that we're in, and then it's ERR 188044 file 1. So if we go under samples, file 1 and file 2, so we would put a -2, our working directory for that, and then the file name, number 2. Finally, we are going to be changing our directory to where we are, and our method of doing that is we are going to be going over to the terminal, and I will change directory, desktop, tutorial, and I made a folder called my HISAT2. So that's going to be my working directory. That's where it's actually going to dump what is where my SAM file is going to be. So that's why I didn't actually have to tell it where that output file is going, which I'm calling ERR18044 chromosomex.sam. So -s actually tells it to make a SAM file. So essentially I will just copy all this and I close this, go over here, paste, and I can enter, and now it's running. So now it's just a waiting game. Should roughly take about a minute or two. It all depends on what your processor is and how much memory you got. So so here is what we got out of this. So 100% repaired, 9.2% were aligned concordantly, 9, 1.23 aligned greater than one time. And then we got a 95.47% overall alignment rate. Now, where that bumped that specific file was my working directory, so I can go over there and see if I actually do have that file. So I'd go into my HISAT2, and there it is. So it's obviously updated. I did it before, but it got updated today, 10:33. So that is how you output a SAM file. I was working on automating a shell, building a shell, a bash shell, so that I could automate this, or a Perl script, but I have not been able to, or I haven't learned how to call programs such as SAM tools or HISAT2 or any of those from a Perl script. I haven't learned that yet, so I will read up on that, and hopefully on the next video I'll be able to build an automated shell for that. Thank you very much. Have a great day.